Hello and welcome to this Mastering the Machine Automation Academy webinar for February 18th, 2023. My guest today was Phil Scruggs, and we discussed microcontrollers and electronics and their applications in industrial automation. Hope you enjoy it. This is a Automation Academy Mastering the Machine webinar for the 18th of February, 2023. We do these every 2 or 3 weeks, and my guest today is Phil Scruggs, who you can possibly see his face up here. But I'm going to go through some of this fun introductory stuff that I usually do. I'm still massaging how to present all this beginning stuff. What is the Automation Academy? This is a membership site where I just keep a lot of my stuff. Lots of downloadable information on topics like we have today. So whatever I've been working on, I've got a couple years worth of library materials in there. And of course, new videos all the time, including a series called Mastering the Machine, which I've got about 5 modules on now. I don't know if anybody's seen that or not yet, but a lot on machine specification, that sort of thing. There is a community with interest groups, IO Central. It's not terribly active. So people do occasionally show up there and leave me a message, and I leave them a message back. But the goal is eventually to turn it into some kind of a social media site where people can exchange technical information on various subjects. And of course, we have these webinars every 3 weeks lately, but I would do it every 2 weeks given a good reason to do it, like Phil showing up here. So having a guest always gives me some incentive to create more material and change the date of the webinar if necessary. Phil is my guest today, and this is pretty much from his LinkedIn profile. It just says condition-based monitoring. It doesn't say where Phil works or anything like that. I do know, last I heard, Phil was living down in Georgia. I assume that that's still true.
Correct. Yep.
Okay. Experience involves product design, testing to areas including industrial engineering, reliability engineering. Phil was at one point up here in Tennessee, close to Knoxville, where I went to school. And I think Phil went to UT also, thus the orange background for his profile maybe there. Current projects include IoT connectivity, data management strategy, and applications toward preventive maintenance on continuously monitored machines. This is very high-tech machine monitoring, not like the typical stuff that we do in PLC monitoring, which can be pretty down and dirty, and definitely not at the low level necessarily like we're talking about today with Raspberry Pis and Arduinos, but I suppose it could head that direction. So I'm going to go ahead and show a little bit of what I'm up to lately and why I'm kind of getting back into microcontrollers and electronics. Not really much going on, but I have made a presentation on Pi plates before. And as you can see, this is a DIN rail mounted Pi plate, the DIN plate, and I still don't even have it wired up. But it is in an enclosure and I can carry it around with me. And then I have this other Raspberry Pi set up. This is another Pi plates set up here. It's called a case plate, and you can, build this up. And if you want to find out more about this, piplates.com, Jerry Wassinger was a guest on here. And this is kind of all my, Raspberry Pi stuff. I've got a little bench in the back that I work on, this little lab, that sort of thing. And then I was not into Arduino much, but recently I picked up an intern. And this intern is a high school senior, and he wanted to work on a lot of this stuff. So I pulled all my stuff out. I have to admit, I didn't do much with this. I had a lot of this material for 5 years and really didn't touch it. And then, of course, a tornado hit my facility, wiped some of it out. But I've gone through some of the exercises. You can see some of the messy stuff we have here. This is my little station, and this is his. And you notice that it's in bags, so we can cart it around. And I've gone through a bunch of the little exercises. You can see here a little temperature and humidity sensor, which I learned a lot about messing with this stuff. But I am still very much a beginner at this. Another thing I did lately that I'd like to kind of mention here is makerspace. I'm not sure if anybody that's watching this knows anything about maker spaces, but most big cities have these. And Nashville, where I live, has one. And this is a pretty cool place. I just went to the open house on a Friday night and I saw all the stuff they did. And they had woodworking and 3D printing and things that I've wanted to get into. They do have electronics, and some people are messing with microcontrollers and microprocessors, but not much. So the electronics part of this is not a real big deal. But what I do is I drive the half hour or so from where I live into here, and I just do some of my pie work and stuff. You notice how this is all in little cases and boxes, and I haul everything down there and set up on a bench just to kind of get involved and hopefully maybe learn more about 3D printing and things. Lots of neat stuff down there. So without any further ado, I'm going to go ahead and introduce Phil here and turn the screen over to him. How you doing today, Phil?
Hey, I'm doing great. Thanks for having me, Frank. Yeah, it's awesome that you were able to kind of show some photos of your Arduino projects. That's actually one of the things that kind of led me into this space 10 years ago or so. And, things like those temperature, humidity sensors, the button press, just, hey, detect when this button is pushed or not. There's a lot of technology out there. There's a lot of development environments that are a lot lower cost to kind of get started with than traditionally in the past, especially with like PLCs. So turning on lights, detecting button presses. If we think of a panel, like in an industrial facility, a lot of those are just switches, lights to indicate a status, and button press to turn on and off, things like that. If you have to go and purchase Allen Bradley hardware and get a fairly expensive license for a piece of software, it can be a little bit limiting for people just getting started, saying, hey, I'm kind of curious about this. I think this can be done, but I have to invest 10K to even get off the starting line. It can be a little prohibitive, whereas Arduino is extremely low cost. We're going to talk a little bit about that with some of the sensors today. But yeah, so I'll go ahead and get started. Hi, my name's Phil Scruggs. I'm currently working in this field with industrial automation and integrating all of the various new technologies that have hit the market in the past 2 or 3 years, in thinking about how to scale those and economically bring those into a facility. So yeah, I work for a manufacturing company here in the Southeast, and that's what I do at the moment. I'll go ahead and get my presentation started. Let me go ahead and share my screen for you. And we'll go ahead and play from the start. Okay, so today's presentation is going to be on low-cost microcontrollers, cameras, and sensors in industry. So you'll start to think about, hey, or you'll start to see a lot of products hitting the market saying they're industrial. Not everything's industrial, but that doesn't mean you can't necessarily start to use it in certain areas. So I'm thinking about going over easy sensors. I guess I call them easy sensors, but they're typical things like temperature, photo eye, door open close sensors. And we can kind of see over time, just a temperature value over time, things like that. So these are typically process sensors, things that you can track over time. They're not bringing in tons of data, just an integer or decimal over time. Next, we're going to talk a little bit about camera image recognition. This is where things get a little bit more complicated. We're going to be focusing on how this is performed on edge devices or devices that are in your facility or in as a part of your project, but not necessarily connected to the internet itself. And then next is bringing it all in. We've all seen these charts before. If you're on this channel, you're familiar with PLCs, SCADA systems, things of that nature. Where do some of these sensors play in this space? Is this the type of thing where we want to bring this in from the cloud, or is this something that's actually on the site? And where does it lie in this framework? So first, I'll get started with low-cost microcontrollers. These things are cheap. All right, we're talking $2 free shipping for some of these microcontrollers. Some of you are familiar with Arduino. Arduino is a low-cost microcontroller. This is called an ESP8266. Let me say that again, ESP8266. You'll find these in a lot of consumer-facing products, smart switches, smart light bulbs. This is basically the chip that gives it the smarts. And really what it is just a Wi-Fi chip and Bluetooth chip on a microcontroller. This type of device is great for bringing in, I call them fairly simple sensors, but temperature, induction, digital or analog sensors with the appropriate hardware, emphasis on appropriate hardware. And a lot of these devices are being incorporated into products that are increasingly reliable. So some are starting to meet modern standards that you'd expect for an industrial sensor. Generally, if we're going to focus on this type of hardware, there's a lot of things that can be done. I've done a lot of projects where we'll bring in a sensor, temperature, for instance, or a photo eye, and we will send this to an MQTT broker. A lot of people will recognize the communication protocol MQTT. It's basically a way of sending messages from one device to another, and it follows something called a publish subscribe model. And generally you could have a lot of these devices. Here's 5 in this picture right here, and you could have each of these connected to a sensor, sending data to a broker. So these would all potentially go to the same broker, different brokers, that type of thing. These are increasingly easy to program. 5 to 10 years ago, they were somewhat challenging. You had to have certain software. The drivers were very finicky. But today you can program these very easily using Visual Studio Code, Arduino framework. Arduino has a new IDE. And there's a lot of different ways that you can program these devices now. And they support a lot of different languages. So just basic programming in any of them will generally get you on the right path. So yeah, this is generally the best way for bringing in, it's easier sensors, things that you just want a point a few times a minute to bring in. You're trying to bring in temperature once a minute, or detect a door open or closing. These are generally pretty good pieces of hardware for that. But say you want to take it to the next level. Say you're interested in doing something like mask detection. That was one that was pretty relevant a few years ago, and may still be. But mask detection, detecting the state of a machine, since we're kind of thinking about industrial use cases, detecting whether a machine is operating correctly or not. There's a lot of cases where you'll be in a facility and a correctly operating machine looks one way, and an incorrectly operating machine looks a complete different way. Maybe it's a bottling line, and when it's functional, the bottles are aligned in one way, but when it's not functional, bottles are flying everywhere. Detecting that type of thing with a camera is possible with lower cost hardware today. Most of this is able to be done kind of through, one of the more popular ways to do this is with TinyML. Previously, a lot of these models were done using big data, big servers up in the cloud with GPUs. However, new chips, improvements in the technology allow for more of this to be done on the device itself. They're increasingly low power for wireless battery-powered applications. So here's an example. Inside of a facility, you're trying to detect people, how many people are in a facility at once, maybe unauthorized access, things of that nature. You can do that using cameras and microcontrollers. Now, one of the things I want to say is a microcontroller is obviously a silicon chip. It's able to interact with this camera and do certain functions. However, it's not necessarily a full operating system. You don't have Linux or Windows on this device. You don't have Linux or Windows on this device over here. You have a camera, you have a microcontroller, which this is obviously a more pricey microcontroller than the ones we were previously looking at in this image right here. However, you can't necessarily bring a camera in with these. However, you can bring in a camera with these and do processing on that stream. One of the things that you can do, or one of the things to notice is it's a lot cheaper than this type of application has been in the past. So this is called OpenCV Oak-D. It's selling for $249. This is called OpenELM VCam H7. I know the board sells for $85. You get a choice of different camera modules to use. Those range in price. I can't remember off the top of my head, but they're less than $100. And then when it comes to other vendors, NVIDIA Jetson has a module with a GPU on it, and each of these small cameras can be plugged into that. So it's fairly standardized to where different vendors' sensors and cameras will work with these devices. One of the, I guess we'll talk a little bit more about this. Some of these actually have a operating system on board, so Linux and tools, things of that nature to bring these camera streams in. But really what we want to do is we want to program these devices to detect the people or detect the problem you're trying to do on the device itself. So with this OpenCV Oak-D, you have a lot of different packages for certain functions. One would be person detection. When a person is detected, this device itself knows a person is detected. This is not connected to the internet necessarily. All of that can be done on this device itself. That's one of the big changes that's happening recently, is enabling these devices to detect people, detect things on the device itself, rather than relying on a connection to the internet to perform the processing and then come back down to the camera to deliver a result. That's going to be important when we talk about latency and things in the next slide. So really, how valuable is data? It really matters on how fast you can use it and where you can use it. So when we take a look at some of these more traditional industrial architectures, how do we use this data? How do we take a camera that's detected a person and says, hey, a person is here, and do anything with it? Well, if you're going to be interacting with facility equipment in any capacity, you generally have to match it to a standard. One of the more popular ones today is OPC-UA. That's how PLCs and factory automation controllers talk to one another. And if you're able to take a tag, generate a tag, for instance, that says person is detected here, 1 or 0, just binary tag, you're able to incorporate it into this framework to where something can be done with this action. We want to be able to facilitate this in some way. So if a camera detects a person, the microprocessor processes it and says, hey, this is really a person. You're then able to take that, plug it into some area of this architecture to where other devices can use that and perform an action on that. Earlier, Frank mentioned the Raspberry Pi. This is a really popular method for doing that. So taking a result that's generated from these devices and then sticking it onto a Raspberry Pi in some way. There's a lot of different methods for getting it onto the Raspberry Pi, of course. But generally with this Raspberry Pi, very low cost computer, $5. You can take that, format it to any format you really need to bring it into this architecture at whichever level is necessary. We're not going to get into cybersecurity or anything like that. We're just going to purely talk about, how do you get this in here? And there's a lot of different methods for how to do that. And I'll definitely take some questions at the end if anyone has any. But generally, using a device like this Raspberry Pi Zero is an excellent way to kind of facilitate the flow of that data. The Raspberry Pi isn't always necessary. Most of these microcontrollers can support sending messages via MQTT. So we could detect a person and then send that message to a broker saying person detected, person detected. We're not sending the image. We're not sending large quantities of data. We're only sending one message saying person is detected here. That's much more efficient than necessarily sending a camera stream to a Pi, having the Pi perform it, and then send the message, or even having this image sent all the way to a cloud, analysis performed on the cloud, and then back down. It's not the best for latency, and it's hard to scale that up when you have hundreds of cameras. If we have 100 of these throughout a facility, we know each one of these cameras is doing its own processing. It detects a person. It establishes whether someone is there or not, and then can send that message hundreds of times a second if we need it to an end device somewhere through this framework. So that's pretty much kind of the end of the slideshow for now. What I was really trying to emphasize was there's easier sensors, temperature, photo eyes, using very, very low cost hardware. Next, there's more complex detection that's becoming possible. It's increasingly affordable. This may still be priced high for some markets, but it's definitely coming down and continues to be a more competitive area. And then the last thing is incorporating this into some type of architecture. We really need to be able to focus on taking this and getting it into a network where other devices can interact with that data. Devices like these microcontrollers enable that to happen. And there's really a lot of interesting tools out there, and we can definitely talk about that.
I have a couple questions related to this. One of the things I think I mentioned in a previous webinar, I bought what I thought was going to be one camera for $18, and it turned out to be 4 cameras for $18. Little ribbon cable mountable cameras that you plug into a Pi, right? It's a little slot in there. I got a good image, and I was able to, save it, and I could take it from the room that I'm in now and wirelessly transmit it from the Pi over there. But if it came time to process it or do something, then you have to get into something like this OpenCV. Would that run on a Pi itself? Is there enough horsepower there to run OpenCV on a standard Pi?
Sure. So a lot of vision recognition projects are run on a Raspberry Pi, especially the newer Raspberry Pis. They're packing a lot of horsepower onto those chips now. And so the standard OpenCV library, most of those can be run on a Raspberry Pi. what we get into is when we start to even focus on um, even more constrained devices. So the microcontrollers themselves. That's where you start to run into some issues with certain packages. Uh, there's big efforts underway to migrate a lot of the packages within OpenCV onto more constrained devices. And the reason this is such a big deal is because a Raspberry Pi, we think of that as a constrained device compared to the laptop we typically program with. However, it's pretty challenging to power a Raspberry Pi from a battery for long time periods. When we're implementing a lot of these technologies in a facility, oftentimes the hardware is not necessarily the aspect that prevents it from being implemented. It's running network cables or running power cables to the device themselves. And so if you are able to somehow take this device and free it from the wires, essentially, you really enable the device to scale up to the use case you need it for. And if the dollar driver is big enough, yeah, it makes sense that someone can run 120 volts to a little powered converter to get it to 5 volts for your device. But oftentimes the cable run and the install cost is higher than the hardware you'd ever even consider implementing. So how do we take this hardware that's now $5, $10, $200 and start putting it places? Well, it's still cost prohibitive. So there's been a lot of effort lately to get this technology onto more efficient devices. Microcontrollers are that area. There's tons and tons of low cost, wireless, low power microcontrollers out there. And they've been optimized over decades to do a good job with what they do, which is very specific tasks. And with this brand new kind of image recognition tasks that are being demanded on them, it's taken some work. But the good news is there's a lot of applications where this is becoming doable, and it's becoming in the tool sets to do it for developers like you or me are becoming available to where we can implement these projects using tutorials on the internet, which is fantastic.
Yeah, I got a sales call from the Cognex rep. It was actually yesterday, and the guy came in and he said, we're focused on maybe getting into the lower end of machine vision. So he showed me, and I have a 2000, which is about at their low end, which is 2000 is a good name for it because it's about $2,000 or maybe a little more. He showed me this thing that did AI, right? Some machine learning things, and they have a platform called ViDi. And I said, okay, so this is the low end. How much is this unit? And oh, well, it's $4,500. And I was like, okay, I thought the 2000 was the low end, And he said, no, for machine learning, this is the low end for Cognex. But what you've been showing, obviously, is a scale of magnitude lower than that, although it's not 24. I'd say 24 volts and above are things that we implement in the plant generally, and I've noticed that getting from 5 volts to 24 volts is where a lot of your cost ends up, where you can run a cable to it or whatever. You end up having to put a voltage regulator on it, and you have to protect it from outside influences and things like that. By the time you've done that and then you've commercialized it, probably doubled the price there, you're still at $500, $700, right? Even for these microcontrollers. We've looked at these in the past, and the Pi on a PLC platform, I think their minimum somewhere around $500 probably.
True. No, that's definitely true. There is a lot of cost in taking a development board and turning it into a commercial hardened product. Absolutely. But when we think about a PLC, right, take an Allen Bradley PLC, you could stick it out on a rack in a facility and maybe it would do pretty well. But oftentimes you put it in a panel anyways, right? And so, yes, you've got an industrial hardened product that should be designed to operate in most environments. And that's kind of the selling point of a PLC is, hey, this is a very reliable piece of hardware that can be in a grain mill and covered with dust for 25 years and still function properly. And that's great, but generally facilities I'm at, I see a PLC inside of an enclosure anyway. So take your development board and put it in an enclosure. It's kind of the same kind of deal. So yeah, there's no getting around putting things in enclosures. That Cognex camera, the camera module itself doesn't necessarily have to be in an enclosure. But take your Arduino camera, stick it in a $5 plastic enclosure with a good cable gland, and you're done, so does it have to look fancy? Probably not.
For those who are watching or who will watch later on YouTube, Phil and I got to take a trip down to Miami and look at some of the stuff in a specific plant. And we discussed on the way down there low-cost methods of having a battery-powered or inline cable-powered photo eye that would transmit, be able to transmit its information to a central location that did have power, but being able to either make it battery-powered and so I've kind of progressed with that. I actually bought, Phil, I don't know if you're familiar with the HC12. It's a little basically wireless transmitter, and I got I want to say 10 of them for $40 or something like that. So they're about $4 a piece. Yeah. But
yeah,
if you had to do something, to your point, like with OpenCV or anything that you were transmitting very much message, this thing transmits 40 bytes at a time, and and is pretty slow. I don't remember the speed, but maybe 2400 baud or something like that. But from the standpoint, you can have 100 different addresses and you can locate these things out. So the first thing I'm going to do is connect one to an Arduino and power it with a battery and put it on some wheels and hopefully let it run around here and every once in a while transmit its status. And that's towards the end of having just a digital point that reports, right, that tells me, oh, I'm stuck in the corner, or I'm running. Periodically just say, yep, I'm running, that kind of thing, and then link it to a Pi. So that's my the low end version of this thing.
Absolutely. Well, it's hard to talk about Internet of Things devices without bringing wireless transmission of that data into the picture. So when we're talking about kind of that edge microcontroller, so that open MV camera, for instance, that's performing a mask detection or something. The device you just described, the HC12, is a perfectly good device for transmitting mask detect or not. If a mask is detected and you've programmed a 1 to indicate mask is on and a 0 to indicate mask is off, and you're transmitting a few times a minute, that's it, no more than that, then an HC12 is perfectly sufficient for transmitting that message to wherever you're trying to deliver it, because all we're transmitting is a 1 and a 0. That fits within 40 bytes pretty easily.
Yep.
That's it.
So one of the things
we're not transmitting a whole image.
One of the things that comes to mind is I see on the news a lot of times robberies, right, in stores, and they have cameras and they catch a picture of the person. But imagine if you can program something that recognizes a person, you could probably program something that recognizes a gun. So if you had something in these stores that, had a camera running just like it normally does, but it detected that independently that, hey, this person just pulled a gun on the clerk, right? And he's up at the register and he just pulled a gun, which is what I see. I always see videos of that. Right then, without any pressing any buttons or anything, if it alerted the cops and it's 3 o'clock in the morning, I wonder how realistic that is on a low level, right? Because the cost of these things, like you mentioned them, they're less than $1,000 for sure by the time you build the whole package. I don't know how reliable it would be.
Yeah, I mean, that's another thing is the reliability is pretty important for some of these systems. Previously, I was kind of discussing with a colleague, and she had mentioned there aren't very many safety rated camera systems out there. So even if it's not necessarily a wireless system, or maybe it's not even using a lot of machine learning, I guess you could say super complex models that are less than reliable. I did do some scanning recently, and it appears that SICK, the manufacturer, SICK, SICK,
Yep, SICK Optic
offers something that they call a safety rated camera. I'm not sure exactly what safety standard that means, but it seemed like it was marketed towards the same type of systems that you would use a safety rated PLC or control system for. So the ones that typically have built-in redundancy in the things that I don't study these systems extensively, but safety systems, which is a whole nother topic.
Yeah, I can probably speak to that a little bit. A human being in a safe area it's like light curtains, right? You have light curtains, you have floor scanners to make sure that, but the problem is you have like legs of conveyors and things like that you have to write out of the safety profiles. So that's probably where that's being used, is a human being in a robot's envelope or something like that. Yeah, we do have a question here. If the controller can contact the police, you could possibly send a video feed and let the police decide what to do with the event. Exactly.
Well, so when I was describing earlier, kind of with the edge-based microcontroller devices, that's the program, the processing, everything is being done on that device, on the end node. There's no connectivity out beyond the message saying, this is the result of what we processed.
Yeah.
So in that regards, an HC12, like a super low cost communication module that you described earlier, that's not going to be able to send a image very quickly.
What he's saying, I understand this point. If the cops had feeds, because there's a lot of incentive for these stores and things not to be robbed. So, and I would say, since they're private ownership, they don't fall under the thing where the public's saying, well, I don't want like the license plate reader cameras. Those are a different story. They're in the public domain. But a store is a little different story. A liquor store, an all.
Well, correct. But at that point, you wouldn't necessarily need processing on a microcontroller on a wireless node somewhere in a facility, right? You would need something. You would need that IP camera plugged into a device with enough horsepower to transmit a live video feed. So that gets into a completely different area.
Yeah, that's being done anyway, though, is my point. Those cameras already exist. They're there monitoring all the time. And what they do is they go back to the DVRs and they pull the records from the DVRs. But there's a live feed. I have one in my house. I have 9 cameras on it.
Correct. Yes.
Yeah.
Absolutely.
And so if I wanted to, transmit that's an easy thing to do. And it wouldn't cost much for that store to say to the police, hey, we want to be on your monitoring feed, and here's the thing that triggers it, and it's live all the time, but they don't necessarily access it unless somebody walks in, and it just has to recognize a human being just walked up and pulled a large object into his hand and pointed it at somebody. Now there's no button to press, there's no nothing, and the cops could just say, okay, we'll go to the live feed and see if it's a real thing. Yeah,
Mhm.
yeah. So, I think there's potential for things like that that are just, yeah, go, no go. And then, yeah, a human being can evaluate it at some point. But yeah, they just have to have access to the feed, like you said.
So I guess one additional thing I'd like to kind of show, I'll go ahead and share really quick if
Sure.
possible, is how easy it is to kind of implement some of these basic machine learning tasks onto a microcontroller. So this isn't necessarily detecting a robbery in progress. It's more simple things like detecting a line, detecting a person's face in an image, um, things of that nature. So things you would often encounter with like small robotics applications or things like that. Am I sharing yet? Let me go ahead
No,
and
not yet.
share. Okay.
There we go.
So one of these IDEs that's available for free, you can download this today, is called OpenMV IDE. And when you download this, it comes with examples, just like when you first started playing around with your Arduinos. And for Arduino, it was like serial read, button press, Wi-Fi connect, really basic stuff like that. This one is, hey, get a snapshot. I'm not sure what Frog Eye is. Lepton is a pretty cool one where it's an infrared camera. What type of stuff can we do? We could do image classification, object detection, barcodes. Barcodes are a big one. Feature detection, find circles, edge detect, key points. All of these are ready to go. You just click on it and go with it. So say we wanted to do find barcodes. Here's the code right here. And you plug your camera in, push upload, and now you are on the road to reading barcodes. And we're talking about $100 device with free software. I mean, there's really a lot of potential with this type of software and these types of devices. It's really exciting. Um,
And again, lots of examples on the internet.
so anyways, I wanted to just kind of show how many examples are provided for free with the initial software. And it's really a fascinating time because, I mean, how much would Cognex charge for their software with some of their preloaded scripts?
Yeah, the
It's not
software
cheap.
actually is free from Cognex, but it only
Okay.
works with their platforms, and that's the issue, right? You can't use their software on anything else other than a Cognex camera. You can practice with it. You can open the software and run an
Mhm.
image that you captured from anything, but it won't work with, and it's not very real time in that case, right? So
Yeah, I don't want to turn the conversation into a what's a good business model because it's hard to sustain yourself if you give everything away for free. So obviously that won't necessarily work, but um,
so
it
what's the
it
difference
also
between
does limit.
OpenCV and OpenMV?
OpenMV is just taking a lot of the OpenCV packages and compressing them down to where they would run efficiently on a microcontroller. A lot of the packages within OpenCV won't necessarily work with a Cortex M7, like a cheap, a lower cost, more power efficient microcontroller. OpenCV works fine for Raspberry Pis, but you can't deploy a battery powered Raspberry Pi for any amount of time over a few months. Say we're trying to do image detection for 5 to 10 years on a battery powered device. You're probably not going to be able to do that unless it's a pretty giant battery. We're talking like 2 or 3 automotive size
Mhm.
lead acid batteries, or a solar powered backup device. And so of course you can run Raspberry Pis with solar power, but what if you want to do it inside? you know,
Yeah, yeah.
oh, plug it in.
Inside, what I've found is in plants, it's not hard to get 24 volts from anywhere. I
Mhm.
mean, but the cabling is a real thing. We talked about being able to deploy these on, just stick them on Velcro to the side of conveyors, but that's really only the detecting device. Whereas a camera, yes, it's a expensive and power consuming detecting device rather than just a discrete signal. But yeah, there's not, especially for cameras, I think there's not much of a problem getting 24 volts just about anywhere in a plant. You're running a sensor cable, which probably has a couple redundant wires. You don't necessarily need the on-off signal, but then wirelessly from there, or even they have a lot of power, basically serial power returning on the power leads possibilities there too. So, serial like this little, I was surprised. My HC12 apparently arrived this morning while I was here at my office at my house. So I have 10 of them waiting for me at home. But one of the things I found when I researched it is it does serial communications, just wired serial communications also. So you could do your wireless up to 1,000 meters, plus you could do over the power cable, a little bit of electronics, and you could transmit a serial string back over the existing power cables, just like X10 technology, right? Which has been used in house, home automation for a long time. They've had that out for 30 plus years, and it transmits serial strings over your power leads in your house and back. You just plug it into the wall and then the device picks it up. So there's a lot of possibilities out there to do that kind of thing. Yeah.
Interesting. Yeah. I'm not actually super familiar with X10, so I'm glad you brought that up. That's really interesting.
Yeah, and there's something better now. I don't know what it is, but X10 was out when I was in college, and I was a 30-year-old freshman. So that was in 1990. X10 was already out. Leviton made these devices, and Leviton's just a home wiring device manufacturer, and it was $10 for a plug that you could put in the wall that basically you could remotely turn on and off. It just had a relay in it, but it sent serial strings. At that time it was even pre-Windows, so you had to use DOS. But and then Windows 3.1 came out, and they gave a free set of software even back then that would send these strings, right? And you had other little devices. You had to, like, in your house, you have two legs of 120, right? You got 240. And so there was a crossover that would send the messages from one side of the panel to the other side of the panel, but it would go out and address all these remote 120 things. And you could just plug a smart lamp into it, even back in 1990, right? And it would turn it on and off.
Yeah, that's interesting for sure.
Yeah.
Yeah. So when we start to talk a lot about I guess that as the conversation moves to data transmission, there's just as many choices to utilize there as there are microcontrollers to implement the program to do the sensor detecting that we're trying to accomplish as well. Leviton sounds pretty interesting with our X10.
I think something's replaced it. I don't think it's X10's still out there, but I think there's something way faster and way better, just like power over Ethernet. There's
of course.
There's things out there now, and wireless has gone so far from now that I don't think they necessarily need to send the signals over the cables in your house. You just put a Bluetooth receiver in your plug, and
generally wireless is easier to implement and oftentimes cheaper. Definitely. One of the one of the big challenge areas though in this area is really focusing on keeping cost as low as possible in order to make these devices economical. For like home automation or one-offs, it's okay for prices to be a little bit higher. But when you start thinking about all the things that can be done with instrumenting a whole city or a whole facility with thousands of sensors versus just 10 or 15, cost becomes a little bit more important, especially, or say you are a company and you're producing these to sell. Your goal is to get that printed circuit board as cheap as possible. And so oftentimes that is using a legacy technology like X10 You know, if X10 is even cheaper than those wireless modules you sent, maybe that's a good way to go. You know, I never want to count something out just because it's old. I'm encountering more Modbus devices than I would care to, and incorporating those into industrial control systems is usually not too hard. There's a lot of ways to do it, but it's definitely not the newest way to do it, but it's tried and true and generally fairly cheap. So companies like to keep using it
Yeah.
with their devices. So the same can be said for industrial Internet of Things. There's a lot of protocols that are out. Like the newest one is Matter, Matter, and Leviton. Several Leviton devices now utilize that. It's worth checking out.
Okay.
But the hardware it uses is newer. It's more capable, but it's also more expensive. So that's kind of where, what are we really trying to accomplish versus how many fancy features can we add? You know, if we're just tracking temperature, a high schooler's Arduino project can usually get the job done, actually, in a pretty good way. But if we're trying to outfit a whole facility with 5,000 temperature sensors and we don't want to run a wire to each one, maybe it makes sense. And maybe we don't, you know, maybe we don't want to have 10 gateways with Raspberry Pis in them. Maybe we only want one gateway. How can we have these sensors mesh together to all come through one point? And that's where newer technologies with more capabilities start to make sense.
Sure. I think, you know, if people set up all the protocols ahead of time, each one of the gateways could be, just like you said, though, one of those Picos. You know, that can do just simple parsing and can recognize its own family of sensors that are out there transmitting to it. But again, commercializing it, you know, and making it rugged enough, and you know, that's I think where the tricky part comes. But what I'm seeing is a lot of the stuff that's coming into the home automation and hobbyist forms are very inexpensive, and then people turn them into something that can be used in industry, which is making the cost, you know, in general go down, which is, it's nice to see. I forget exactly what the topic was, but I mentioned something about, oh, I know what it is. So my intern, right, has done some simple applications and things. He learned about libraries, and he learned about being able to pick up information from these things, but I've noticed he didn't investigate them very deeply. So for instance, he'll do the exercise like on the humidity and temperature sensor, but he just, maybe he thought it was magic. But when you look into what that thing does, right, and I want to say you can buy those in bulk for $4. There's a microprocessor inside, and it is transmitting a string of information for both the humidity and the temperature that you would never guess it, right? I would have thought, oh, maybe it's an analog signal or something, and it goes into the analog terminal. But when I noticed it, it was like, this goes into one of the digital pins on the Arduino.
It's the DHT.
Exactly.
And the D stands for digital.
That's right. And once you start investigating that, it's like, oh, this has come so far. I mean, full disclosure, I'm an electrical engineer. I went to school. It's been 30 some years, but we did microprocessors, and we did assembly language, and we did all that stuff. But the technology itself, it's so tempting to take this little Arduino board and do the exercise and not look into what's really going on behind the scenes, right? And find out, how does it transmit its information? How does the Arduino decode it? What language is it? It's just a bunch of bytes, right? I think that was a 40 byte string, you know, and it was five bytes of information. I didn't even get into what form those bytes of information were. It said like one was digital and one was something else, and there was one pair for each, and then there was a header, you know, string of some kind. And that's kind of the stuff that I want to do once I get these HC12s working with my digital devices, so that I can tell the difference between the different ones. And it actually operates apparently on 100 different frequencies that you can program. So you can tell it, I want you to be, your device number one, and you're on this lower frequency, and then 400 hertz higher, different frequency, is a different device with a different number transmitting back to you. And so build your own gateway and learn from the very basics.
Yep, that's yep, that's interesting. When you say building your own gateway and that type of thing, there's really a lot of different possibilities. So that's why when I was kind of going through my topic or discussion today, it was purely on microcontrollers, the really low cost ones, right? Arduino's ESP32s and 8266s. They're really cheap. They offer a lot of capabilities. There's a lot of tools for interacting with them. And they're using pretty standard protocols, things like Wi-Fi, things like Bluetooth, things that you use on a daily basis. Everyone uses a Bluetooth mouse. Bluetooth is natively supported by their laptops. Every laptop has Wi-Fi, every laptop has Bluetooth. And so those generally are really easy to interact with. Most laptops, especially if you're cheap, right, have a USB port. Some of the newer ones are more limited. But generally communicating with them's pretty good. When it comes to designing a whole system, as far as gateways, sensors, oh my gosh, there's so many possibilities. I try not to talk about those today because we're limited to an hour. But designing your own sensor to gateway method, because there's so many methods, it is a really interesting topic. One that I really like is the mesh technologies, the mesh opportunities.
Yep.
Because when you start stringing sensors out across a large geographic area, it doesn't make sense to run connectivity to each point along the way. If each one of those sensor nodes can receive messages and then ping them or send them to the next destination, you can create really long routes for information to be transmitted. And the lower cost, the cheaper radio transmitters tend not to go as far.
Right.
And so we can lower the cost of implementing lots of sensors by using cheaper, lower cost devices that just ping off of one another in order to get those long distances that we're trying to achieve, versus spending a lot of money for higher cost devices that happen to go a little bit further.
Right. Yeah.
You do reduce your reliability, right? If one of those nodes goes out, everyone down the chain can't talk. But there's ways around that. So,
well, like you said, a mesh, you're talking to several of your neighbors. So if one of your
you got to be able to talk to several neighbors and make sure there's no bottlenecks where if someone fails, because sensors do fail.
Well, it's a lot of fun playing with these little toys. That's kind of new for me. I've been involved with this more expensive industrial stuff for a long time, and I'm still messing with that a lot. Still doing Allen Bradley and Siemens and Beckhoff. I think those are my three main platforms, mostly because that's just what's installed out there, and so that's what I'm getting a call for. But it's fun dealing with these microprocessors and things. And of course, having an intern gives me some incentive.
Yep. I guess one additional thing is oftentimes we do refer to them as toys or not necessarily industrial hardened devices, but just last week I was opening up industrial hardened sensors from vendors. This happened to be filtration devices. It was a filtration controller. It controls kind of oil pumping through a device, and it's an industrial device, right? It's got an aluminum case, a nice screen with push buttons, M12 connectors on the bottom. So it is, it's tried and true industrial device in facilities across the US. And they offer a new version. It's Wi-Fi. Like, oh, that's cool. It's you've got your serial connection, your CAN connection through your M12 cables, and then you've got Wi-Fi. Well, what's inside of there? an ESP32. That's where their wireless is coming from. So, we refer to them as toys, but these are in the light switches in your walls today. These devices are in industrial components as we speak. And so, yes, we can call them toys, but really what they are low-cost sensors. And a lot of them just haven't necessarily been brought into an industrial hardened enclosure.
Yep. Well, that HC12. That was one of the reasons I bought it, is because they said exactly that. It's used for various things, remote monitoring, and it gives all kind of details, what low current draw there is. And
it's really hard to beat that 400 megahertz range for radios. They tend to be half the cost of the Zigbee, Z-Wave, all the other automation or wireless protocols you hear about. The standard is different.
Yep.
I'm not sure if there's as many, there's IEEE standards that each one of these wireless transmission methodologies falls under. And that can play a role in the reliability and the scalability of the solutions, right? It's a big group of people who came together and said, hey, this is really what we want to see. And we'll all play nice so that our devices talk to one another. But
exactly.
that can add cost to the devices. So that 400 megahertz, or the 400, what is it, megahertz, I'm pretty sure?
433 megahertz, yeah.
Yep, 433. That's definitely some of the lowest cost radios I've seen that look really good.
Yeah. One of the things, I'll go ahead and pull the document over here. But this is so when I start working with this thing, this is the one that I downloaded, HC12 wireless serial port communication module, and it talks about all that. So just a simple Google search will help everybody find all these things, right? And do they talk about IEEE here? Stamp hole packet, a lot of just the configuration and things, technical details, Easy Radio Pro family transducer. So it's something somewhat standardized, but when it comes to actually taking those bits and bytes apart, that's going to be a different animal. So you can while away a lot of hours trying to play with this stuff. But again, you can't beat it for a few bucks, right?
Mm-hmm.
That's what it comes down to. Well, I'm going to go ahead and kind of wrap this up. We've done about an hour here. I'd like to thank Phil for hanging out and presenting. I always learn so much because you're working in some areas that I don't get to work in very much. So I always learn a lot whenever you show me what you're working on. I don't know how much of this is related to work and how much of it's just for fun, but I know
it's kind of a combination of both. So that's what's fun about it is, I can't always necessarily talk about my projects purely at work, but I can always talk about my home automation projects and various things that I'm considering at a personal level. So
yeah,
it's always great to chat. And I did recently come across those 400 megahertz radios, and they're about 50% cheaper than most of the Zigbee, Z-Wave thread radios that we're going to encounter and keep encountering in your smart devices for home. So
yeah. And I think they're at 800 and something megahertz, if I remember correctly. And I looked into those, but like you said, the cost was higher. So I figured, well, just for things crawling around on the floor in my shop here, I think I'll try these out. And you get 10 of them in a package. Can't beat that. So
yep, based on your background with PLCs and industrial automation, you're very competent at reading what's coming across that serial. And so you know exactly what's coming across, whereas a lot of developers aren't as familiar with that. And so that's why
they have a bunch of examples, though. So far, everything I've found for any of this Arduino stuff, I find it all over the internet, and people are happy to show you what they've done. So there'll be a YouTube video or whatever it is for it. So go ahead and wrap this up. The next webinar, it looks like, will be March 11th, and I am teaching a NTH University class. It's a simulation Allen Bradley ControlLogix 5000 class, so I'll be showing my I have a simulation that has been just growing and growing for years, and I recently added process control to it. So I think I've shown it on here before. It had pick and places and dial tables and things, and now I've added actually the beverage facility, Phil, that you and I went down and visited. I've added a micro version of that in simulation. So I have 4 tanks and a filling area
Oh,
and
yeah, yeah.
pasteurizers and all that, and I simulate all that just in Allen Bradley RS Logix 5000. So I'll be showing that. That's the day after the class ends. So I'll just bring up my simulation. It's got some fun graphics on it. It's just a Panel View Plus that I run on the computer, but everything runs self-contained. So it's nice. You don't have to have a PLC. You run an emulator and you run the software and no hardware. So that's fun. But thanks, Phil, for hanging out, and we'll see everybody the next time.